Hello children, welcome to channel Sube. Today I am going to discuss question number 46 from the MCQ part of 2019 Physics new syllabus paper. Consider a battery of electromotive force EMF E naught. So E naught is this one, and internal resistance simple R. So it is separately they have given. As shown in the figure, it is connected in series with a resistor R. This one, it is connected in series with a resistor R. A variable DC voltage source which can be reversible. They have used variable voltage source, that means a power supply which can be reversible. Reversible means you can change polarities, say initially like this, and you can change the positive to negative and negative to positive like this. That is what we say reversible. We can change polarities. When the voltage of the variable source VVR, this one, is varied, that means change the voltage, say 3 volt, 4 volt, 5 volt, like that we can change. The graph of I versus V is best represented by, there are 5 graphs, so we have to select the suitable one. So children, first of all you have to identify this circuit, what they have done with this battery. You can do two things with a battery. The one, if we talk about the first one, we can consume the battery. We can consume the battery, say to light up a bulb, or to run a motor or something like that. We can use a battery to consume it. Then the other instant, we can use a battery to charge it. We can charge the battery using a power supply. We give in current in this instant. So here, if we talk about the first one, consume. When we consume the battery, we take the current out, say I, from the positive terminal, then we say we consume. So the electromotive force is E, internal resistance simple R. Then there is a voltage between these terminals, and the same we get across the bulb or the load, whatever it is. So this voltage is always smaller than this electromotive force. So what is the equation we can use to find out that voltage? So there are two equations, you know, but you have to select the correct one here. The equation is V equals E minus IR. E minus IR, because the voltage always is lower than the EMF of the battery when we use the battery as a to consume. Then if we use the battery to charge it, so we have to use another battery whose EMF is greater than this one, say this one E naught, as they given in the question, this one E naught. So here also we can say E naught, then E naught. Then if we want to charge this battery, we have to connect a bigger battery whose voltage is greater than this E naught. So say E2, Then to charge, when we charge the battery, the current flows into the battery from positive plate like this, opposite to this early one. Then what is the equation? The voltage here, there must be a voltage here, the same voltage appears here. So the equation is V equals E plus IR, because the voltage must be greater than this voltage. So E naught here, the voltage given to this battery at these two terminals must be greater than this EMF of this battery, because we force this current to go in. Because normally the pressure from the battery is to this outside. So to overcome that force, we have to use a bigger voltage, greater voltage. So like that we can charge a battery. So now let us go to our question. Here the current they have shown is this way. So the positive terminal of the battery is here. So from these incidents, which one you have to select, because the current goes into the positive terminal of the battery. So this one is the incident that they have done in this question. That means they are charging a battery like this. They are charging the battery, because we can see the direction of the current is into the positive terminal. So here that is what we can see. But you don't have to use these equations, just I showed you to revise. Here you don't have to do any calculations. You have to identify either this battery is being charged or being consumed. So here this battery is being charged. So when a battery is being charged, here we saw the external the voltage of this external power supply must be greater than the battery under charge, the EMF of the battery under charge. So it should be the external power supply must be stronger than this battery. So here therefore this V must be greater than this E naught, because the battery is being charged. So V must be greater than E naught. So you have to select that sort of a graph. So here we can assume this one equals to E naught, and the points we have taken to the graph, we have plotted, the voltage is greater. So this one is correct. If the voltage is smaller, the external voltage is the voltage of the power supply or source, this is source. If the voltage is source is smaller than E naught, we don't get any current. Because we don't have the strength to push the current into the battery whose opposite pressure is E naught. So we have to overcome to get a current through the battery. Therefore, if the external voltage is lower than the EMF of the battery, then we don't get any current. I equals 0. Therefore, in this graph, they have received a current that is negative, but this part is correct. I will explain this part. Let us first see only the positive side. So this part is correct because while the voltage is greater, given external voltage is greater than the EMF of the battery, so there is a current. So this one is correct in that view. Only the positive side let us talk first. So here it is wrong because they have a current at even lower voltage below E0. So below E0 we don't get any current. So here 0, here some value is there, therefore this one is wrong. So now let us talk about this graph. So this crossing value, let us say E0, that is our famous this battery whose EMF is E0. So assume it is 5 volt. So here this one is 5 volt, say positive 5. So what they have done according to the graph, they have increased the external voltage V to positive side. This one is negative. What they have done is increasing the voltage to positive voltage. So we are talking about this part. So that means this voltage has been increased. To happen that this power supply voltage must be increased because this is the source. So without changing polarities, the same as positive, because initial current this way, that means this one positive, higher value, so that then only we get the current that way. So this must be positive, this must be negative. Then we are talking about the higher values than this 5 volt. Here 6, 7, 8, 9, like that it increases, it is increasing. So say 6 volt, 7 volt, 8 volt, 9 volt, like that it is increasing. Then this battery is being charged. This battery is being charged because the current enters the positive side. So we discussed it earlier. It's been charged. So therefore the charging current is determined by the difference between this and this. So initially the difference 6 minus 5, then 1 volt, then according to that a little current is going through this battery. So later the value has been increased here to 9, so this one constant. So 9 minus 5 is now 4, the difference is increased. So therefore this current also must be increased because this pressure from here has been increased. Therefore this current must be increased to the same direction. It can't change to the opposite direction because still this one is higher, this one is lower. So the potential difference is to this way. Therefore the current should be to the same way. Therefore the current must be at positive side, and with the external voltage it must increase like this. At positive direction the current should be, but they have drawn at negative side. This current side is negative, therefore it is wrong. So now let us focus our mind to this one. So let's take this point first. Here the voltage is 0, external voltage is 0, this one 0. The current is some value that is not 0, it is not equal to 0, and also it is positive. It is positive means greater than 0. It is positive because this side is positive, this side is negative. The current axis we can see that point is located at this positive side. So let us again apply some values. So imagine this one is 5 volt, then this one is 0. We are talking about this point 0. Then this power supply has no voltage, that means that also 0. That means we can't say this one positive, this one negative. So there are no polarities, just it is neutral, just it acts as a conductor like this, because there is no voltage. Then this one is still here 5 volt, so this battery is now stronger than this one is 0. So the positive here, negative here, then positive to negative there must be a current. That means here the direction is this way. So initially they have taken this way as positive, but now it is opposite. So the current must be negative at 0 external voltage. So they have shown it at positive side, so it should be here negative side. So therefore this one wrong. So now let us focus our mind to this one, this graph. So here take this point, here voltage is 0, external voltage is 0, then current also 0. So earlier when we were discussing this question, this graph, we saw that here if the voltage is 5, since this one is 0, there is a current to this way. It is not 0 because this one is conducting well, not opposite force, opposite pressure, or not any help, but this one is still there. Therefore there should be a current which is not 0, but here they say it is 0, therefore this one is wrong. So now let us talk about this one. If you look at this side, it is wrong because earlier we discussed the positive side, it should be like this. At least this part should be there, but here this part is wrong, therefore, because this graph should start from here. Earlier we discussed this one. Now let us talk about this one. When the external voltage is negative, this part we are going to talk about. When the external voltage is negative, negative means this one is negative. That means this power supply produce this terminal as negative, this terminal as positive. Earlier it was like this, positive up, negative down. So now negative up, positive down, this way. So you see this positive and this negative are connected terminals. So that means these two cells are in series. So there must be a huge current this way, because this one drives current to this way, because the current comes out from this positive terminal. So this one also drives current this way, because this positive side is there. Nobody is opposing it. So earlier this side was positive, it was a huge one, therefore it won to this side, it drives current this way. But now this side is negative, that means pulling current. So this one is pushing, so pulling and pushing add all together and the strength increases, therefore the opposite current this way increases. Therefore they show that this one at positive side, so they are wrong. It must be at negative side like this, or at least this side, this way, somehow negative side. So therefore this one is wrong.